Hello everyone, this is Mingshu from Ming Trio. Mingshu is in Silicon Valley, and I'm really happy, and what a coincidence, to be able to sit down with two very representative figures in our database world.
Big company and small company.
Right. So I'll start with Mohan. Mohan is the IBM fellow and also distinguished guest professor in Tsinghua University
And Hong Kong Baptist.
and Hong Kong
Baptist
University. Okay. And Mohan and I had a couple of interviews and interactions last year in China.
Right.
He's the I call it guru of database and pioneer, of our database age, right?
Yeah.
And on my right hand, Huang Dongxu, Ed Huang, is the founder of a very famous database company, PingCAP. Right.
Open source.
Right, and so we're really lucky to have a chance to sit down in the Silicon Valley office of PingCAP, and look in the back. Our topic today is the future of database.
Mm-hmm.
So I'll kick it off. From your age, from my age, and from Dongxu's age, database has grown. Dramatically, heaven and earth, I could say. But my sense is database has been and will be the core of the IT infrastructure, no matter what. And I had a theory that database is the most important piece of the whole infrastructure from all the layers.
People have said data is the oil.
Right, data is the oil. Now people say AI is the oil. Whatever. We have many oils.
We say data is still the core of AI.
Right. So we have gone through many generations of revolution, evolution, modification, and things around database. But I think this is crucial in July 2025. I think is at a crucial moment or turning point of the database. Where is database going to go from here? And with all the renovation or innovation of AI and so influential. Yeah. Everybody is talking about AI, and people seem to be forgetting about database.
But although I would say, based on attending last year's SIGMOD, VLDB, ICD conferences, and having just come back from the SIGMOD conference in Berlin, there is quite a lot of discussion about the synergistic interactions between AI and databases.
Right.
So people aren't sort of dismissive of database technology or the value databases bring to the table, even in the context of AI. And so to that extent, I would say that Silicon Valley in particular, with all the AI language models that are being developed right around here by Google and OpenAI and Facebook and such companies, there is quite a lot that's going on. In fact, I'm about to have a session on AI plus databases at the Northern California Database Day, which will be held on October 3rd, this time around in Oracle. It sort of moves around in the valley. So the panel will be on AI plus databases, and I'll have people from Google, from OpenAI. There are two other companies being represented.
I like the term you mentioned about the turning point,
right?
Because in the early days of the AI or LLM, this hype,
starting from 22,
right? Later 22. And the ChatGPT without your personal data or personal context is just like an interactive Wikipedia. It is useful, but it is just like a
encyclopedia.
It's a the
too general.
Yeah,
it's not
too general. It's not
personalized.
Yeah, it's not useful. I would say. But in the future, if you want to actually make something actually useful for your business or your
personal use case,
because you need to combine it with your own data.
Right.
So I'm happy to see the whole industry. From the LLM level, today the LLM based model is smart enough to build something useful. The second thing is all the tool use or the infrastructure is actually ready to let the LLM to access your data source, like MCP or text to SQL, all kind of new technology. So I think it is the turning point that made me think, hey, in the old day, the database is actually designed for the developers, data scientists, and DBAs.
Right.
But nowadays, what if we need to design the database interface to the AI agent? So what's the AI-friendly product form for the LLM to access your data? So I think that's a little bit thinking out of the box. Today, if we think we are the AI agent, what's the capability we need from the database or data source?
Yeah, I think this is very interesting angle because we all know that throughout the evolution of databases, as I mentioned earlier, there are tools that were designed to help the end users to have better query capability, better presentation, better results. Mm-hmm. So because we all know that database is just an engine or is a tool, but it doesn't take you to anywhere. Our purpose is not playing on the database. Our purpose is going somewhere.
Make use of the database.
Getting something done, right? Yeah. For example, I need to see the financial report. I know everything is in the database, and I know there are ways to query them. But what if I am the PM, I'm the portfolio manager. I need to see the results instead of knowing how to query.
Interestingly enough, Damshu, you might not be aware, I think I mentioned it to you, Tom, that in the case of my own career beginning in December 81 at IBM's what then was called the San Jose Research Lab, the birthplace of relational and SQL. The project that Ted Cord, the father of the relational model, was doing was called Rendezvous, and it was an attempt to provide, believe it or not, natural language access to System R. 43 and a half years ago, guys. Right. And it's still the topic of intense research and products being released and so on by Microsoft and AWS and people like that.
So that's kind of the swirl of
the other thing that actually today I'm still an engineer. I'm still writing code. I'm actually doing something to make LLM to have a good access to our database. Mm-hmm. First, the insight is SQL is still the best thing we have.
Absolutely.
Yeah. Imagine you are the LLM. If you're interacting with a key value database, it will be really hard because the key value is a very simple interface. But the SQL is, very powerful, flexible, and more importantly, it is 100% correct. If you write it,
unambiguous.
Yes.
Then NLP being ambiguous, right? Yes. So one of the points I keep raising with people is, who are you targeting this natural language access to databases? If you're targeting the naive user who doesn't know SQL, since the natural language is ambiguous, how are you going to validate the interpretation that the system gave and it transformed the natural language query into a formal SQL query, that was the intended interpretation, because the naive user can't make sense of the SQL that you generate. So if you are targeting the SQL knowledgeable user, why the heck would you even bother to use natural language when he or she can more precisely state the requirements using SQL itself, if they are already knowledgeable. Exactly. So I'm still a bit unsure of the value of NLP access to databases. But the related thing I wanted to make a point about is the fact that one of the companies whose work is not getting enough visibility is what IBM has been doing with its Granite models, which are intended, first of all, they are open source. Secondly, they are intended for the enterprise environment where they don't want to treat all the world's data equally well and, make sense of all the inconsistencies and so on. So they want to make use of only data sources that are being deemed to be trustworthy, reliable, and so on. So they also want to generate LLMs that are domain specific. So enterprise ready and domain specific. And these are called Granite models. And they are even working with the Facebook guys, the Llama guys, because they are in the open source arena.
So it's like a trustworthy data source chained LLM system.
So they also provide guarantees, indemnification for people who make use of these Granite models. In case somebody sues them that they are violating some copyrights, that. IBM is so confident about the homework that they have done in making use of data that is in the clear and not subject to copyright and such. So to that extent, they are indemnifying the users of the Granite models. But people don't, talk as much about.
Because today most of the engineers are just in the building application running so fast. I think you're right. Maybe we should spend more attention to the underlying the trust of the data.
So when I was at Huawei, I think back in 2016, we actually, I think it's safe to reveal now that we actually had projects on AI inside of database.
AI for database.
Right, AI for database. Yes. So I think there's two kind of terms. Right. One is AI for database and is database for AI. Let's talk about these two sort of trends separately. What you were mentioning was more like a database for AI.
Or maybe data for AI.
Data for AI. Yes. Right. But I still want to talk about the first or more easily visualized benefit of the AI trend, which is how can AI benefit the database?
That's where all these recent projects on trying to leverage AI technology for query optimization, dynamically modifying the way the query optimizer handles different kinds of queries as the schema changes or the data instances change or the workloads change. Instead of hardwiring the cost models and various other aspects of query optimization, they now are, at least in the research kind of context, working on leveraging machine learning kind of ideas within the guts of the database system to be able to have more realistic kind of query optimizations being performed, rather than what my first manager at IBM, Pat Selinger, came up with in the context of System R as the first ever cost-based query optimizer.
My view is I don't feel because first the hallucination, the second is the performance, because we are doing OLTP workload. The first thing is the performance latency. The second thing is most of the online incident in the OLTP scenario, which is the query plan change to that will cause a lot of unstable
regression in performance and so on. From a release to release.
Yeah, I maybe treat AI as the sidecar to our SQL optimizer, index advisor. To review your schema, hey, this is not the correct index. You should create the index on another column. And also, we use the AI to, just like you mentioned, SQL rewrite is actually the very useful scenario.
Right.
On the other side, because we are also doing the enterprise database business, so we put the AI in a lot of post-sales process, like resolve the ticket, help our engineer to figure out
root cause
analysis.
And identify similar situations and leverage solutions from the past. That
I want to use AI to help me to do the performance automatically build the environment to do the benchmark.
Oh, I see. To generate synthetic workloads and such things.
Yes, and
to test the performance.
To test the performance and
not just go with standard benchmarks, but also adapt the workloads that your system might be subject.
This is the first step, environment. The second step is I will open the access of our source code. So let AI agent to change the code to say the target or the goal is improve the performance. But so I want to try to build the R reinforcement learning process to make AI to automatically optimize the database kernel for the better performance,
or for stability, or for more flexibility, or whatever. Right?
I wonder whether along those lines, if you want to have your code be portable enough to run in different hardware and operating system and middleware environments, whether AI could help you in adapting the code to more specific operating environments, even though you wrote the initial code for a certain specific environment.
That's interesting observation, because that's a tedious work,
right? Exactly,
and that's very suitable for AI.
Yes.
That you give it.
In fact, this might come up in the context of the composable data systems workshop. That I've asked Dongju to be a panelist in.
I
can
share some number and have some progress in the workshop.
Right.
Nice.
But of course, going back to 2016, we were more on the analytics side because that you deal with big and long queries that would take hours instead of taking seconds. But then the goal is to ask AI to read all these query plans or all the queries through different query plans, see if there's a better path that the automated query plans or optimizer didn't pick.
Yeah,
right.
So that's the sort of thing I was referring to before that I kind of summarized in the talk I prepared the request of the Google guys when I was consulting for them in 2022. So there's a bunch of work along those lines that's been done in the more recent past by Microsoft people and others who have tried out some of these things. But I still characterize a lot of these as research efforts rather than ready for prime time and for deployment in production environments. Because as you said, if an existing query winds up taking much longer time with this more advanced optimizer compared to the past, people are not going to be happy. If you tell them on the average, this new optimizer is better than the old optimizer, they'll say, who cares? There's not socialism. I want my query not to degenerate.
But the challenge, I think the real challenge is, you can sell me sort of a new optimizer, but how are my existing systems going to behave, right? You're telling everybody, hey, there's a new path. When everybody is sort of looking scrambling for the new path, then my current business is unstable. That's what the business hates, right? And that's really our infrastructure guys need to take into consideration, right? Plus the illusion. The illusion of AI, that's seriously challenging, isn't it?
Yeah, correct.
See, the other thing that they've observed with these query plans, especially in the context of the cloud, is that if you pre-allocate resources even at the beginning of a particular query's execution, then they observed in various cases that the resource consumption during the execution of the query, whether you are looking at CPU or memory or I/O and so on, varies quite a bit. So pre-allocating resources and getting charged at that pre-allocated resource level is not a good idea, is what the Microsoft guys have observed. And so they have a paper where they discuss all this and say the usage charge should happen as actual usage happens rather than as predefined at the beginning of the query.
I think you get the very important point, which is pre-allocation. It is, besides of the AI, another big transition is today is the cloud, how to leverage the cloud infrastructure. So elasticity of the infrastructure. I would say, the traditional database, they're actually not designed for the elastic infrastructure. So, for example, today we have, TiDB, we have another branch which we call TiDB serverless. This is a new, we built a whole serverless engine from ground up.
Wow.
Yeah, because what you are building is not the database software. It is a database service. When you are building the service, you are actually from day one, you're designing this service for millions of tenants, millions of customers. So you can easily leverage. And the second thing is, if you are designing the service, you need to consider the elasticity on different levels.
Absolutely.
Yeah. So
compute level.
Yeah, compute level, memory level, and the cost.
I/O and
I/O
storage.
Cost. Yes. And I totally agree with you. For example, one customer, if they want to analyze a big amount of data, but this query only every day only run once every day. You cannot pre-allot like hundreds of nodes for this customer for this query. You need to say, hey, if you run this query, this super heavy OLAP query, I can launch 100 nodes immediately, finish the job, and return back to the pool. So it's all about cost.
Yeah, exactly. But I think the challenge is, of course, cost is one thing, but also sort of the optimal solution for everybody, like a socialism. Of course, you have the money. I can give you as much resource as you want, but I have to also maintain sort of the service level agreement with everybody else.
The other people.
Just like on my way to here.
You also have to be competitive with respect to the other cloud vendors, right?
Exactly.
Whether you're comparing Microsoft Azure Cloud or AWS or Google Cloud.
Exactly. Just like, of course, the digital resources are a lot easier than the physical resource. Just on my way to here, I asked the Uber driver to take the express lane, and that would charge me.
Right.
20% more. But I think it's worth it because it gives me 10 more minutes, which is crucial, right? But in the database world, I guess if I need 20 lanes, would you be able to give it to me that quickly and at the cost of everybody else? Are you able to get more lanes yourself and allocate it to me, or you somehow make a adjustment within the 5 lanes that you only have?
As long as you don't violate the SLA agreements.
Right, and another thing is really more tricky, which is business-wise. Are you able to charge me enough money to recoup sort of the damage that you need to explain to other people? Hey, there's is a prince from Middle East coming, and I'm getting millions of dollars for him, and I promise you next year I'll build 1 more lane for everybody. Maybe that's a theory that can win the quorum, right? But otherwise you're limited. And I think that's the tricky part. Before the cloud came, we don't have that choice. Now we do have that choice, but we still need to have. We still need to.
The problem is that we have
decision.
too many
choices, right?
Yes. But I think AI will play back to the AI. Will play a very important role.
Exactly.
Yes.
Exactly.
It is an optimization problem, and we have a lot of choice. There is not the optimal, most optimal the solution. So that's why I'm thinking, hey, maybe AI can give a reasonable, the feedbacks or the answer to it.
Exactly. So that's the hope.
Yeah.
That's the hope, and that's why we're talking about the future of
So
database.
basically, we are saying AI can provide you better adaptability because it can monitor what's going on, and if things change over time, both on the workload side as well as the resource availability side, it can make the whole environment become more.
I think in this whole trend of so-called the future of database, the AI for database, I'd like to categorize that as a very experienced DBA guru. That doesn't necessarily make real-time decisions. Say, hey, I'll allocate 20% more CPU to this particular job, but as a whole, I look, thousands of millions of transactions and look at their execution time, look at their IOs, look at the cost of the cloud resources, blah, 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 blah. We can train this guy, the agent, to be so experienced and knowledgeable and smart.
See, the other consideration is also the powerful CPUs versus not so powerful CPUs, and using GPUs versus some other way of speeding up.
And I/O competitions and all that.
So there are so many different networking technologies also that are available, and so RDMA versus something else.
Right. But in the end, the goal is to come up with some kind of a smart solution that will guide everybody on this highway to
but there are many things to be optimized, right?
I know.
For the user, response time and overall cost, but also for the service provider, they want to improve their profits and be competitive vis-a-vis their competition.
I would say if today the senior DBA, what a senior DBA can do, I think AI also can do the same.
You think it's 100% taking it?
Yes.
Okay.
But all the what we discuss is based on the assumption that we are using AI to optimize current workload. But I think with the help of AI, the database will have more new workloads. For example, like when we talk a lot about OLAP, data analytic, ETL process, big data. Why we need big data? Because in the old day, we don't have the human being cannot analyze everyone's personal data, right? Mm-hmm. So that we need to gather all the data here and there together to do some, OLAP, ETL to get insight from the big data chain. But imagine that in the area of AI agent, everyone will have their own DBA, their own AI agent. So maybe small data, it will be the new channel. In the future,
smaller data,
yeah.
Lots of them though.
Lots of them, yes.
Right. Lots of small data islands.
Right,
yes.
right. Autonomous data sets,
right.
Yeah, for example, I built a very interesting prototype this morning. I put all my personal data into my database, and I just asked
his digital secretary.
And I asked a question. Find today's email about the airline and give me a summary. And the AI will actually write the SQL to query the data and just give me all the summaries. I don't care the SQL he wrote, but I only care about my personal
end result.
And the result. And I think in the future, that will, from the database engineer perspective, this trend will lead to some. For example, in the old day, when we designing the distributed database, the data volume or the capacity is the bottleneck. We need to design this, the system to store a big amount of data. But with this trend, you will find that the bottleneck is actually in the metadata. How your database can support millions of tables, small tables, because it's just personal data. So I think maybe.
In fact, an interesting thing happened when IBM bought Lotus, and Lotus Notes was the main attraction there. And in the case of Lotus Notes, each of the Notes users' mailbox was a separate database. And now they were trying to, in the case of some large customers who had tens of thousands of such databases, shove them all into a single DB2 database. The way they mapped these individuals' databases, and that was a document data model, right? Onto a relational one also led to some strange things that were not easily dealt with in the context of a single table, where within that table you had to distinguish these different users' notes databases. And a similar thing happened even at Google when they took a document model database system called Firestore.
Firestore, yes.
Initially dealt with the file system directly, but then they decided to make it run on top of Spanner, which was a more relational, record-oriented data model with a few additional features than traditional normalized tables and so on. And there again, they ran into a number of issues because they are now trying to map totally different kinds of documents into a more structured kind of data model, and they had to design the indexes and so on very differently.
Yes,
so this keeps coming up, where you are trying to benefit from the high reliability and worldwide geographically distributed databases with stringent response time requirements by mapping onto it all sorts of different kinds of databases designed with different data models and such.
So that's why I'm saying distributed database and the cloud build a very good foundation already,
right?
So that today we can enable the AI to have a better access.
Because this is still, we're talking about layers, of the infrastructure. When the fundamental layer is changing, database, I think the future. I'm a true believer of whatever the top layer will definitely follow the bottom layer's evolution. If they moved all the way from server-based, from on-premise to on cloud, then the top layer should go there, right?
See, I'm also curious about the other aspect. Like, I'm sure you guys are aware that OpenAI went and bought this company. The one,
Rockset.
Yeah, Rockset. Yeah. It's a database company.
And also Databricks acquired NeoDB.
Right. So in the case of Rockset, the founder, CTO, Dhruba, he's going to be in my panel at this NorCal Database Day on October 3rd. So I'm curious to find out what they're up to in terms of how they're going to leverage database technology in the context of OpenAI. And equally well, I'm also going to have in that panel, this is the name I forgot before, I'm going to have Matej Zaharia, whose PhD thesis was the basis for Spark. So Matej is not only a professor at Berkeley, but he's also founder and I don't know what title he has at Databricks.
CTO and co-founder.
Yeah, so he is also part of this panel, and I'm curious to find out what they're going to be doing with Neon database that they acquired.
So to summarize, we touched quite a bit about the AI for DB trend. Is there anything that you guys want to talk about, continue on that topic, AI for DB?
I think that's as you said at one point, somewhat easier thing to do because it involves the innards. One area that I do normally bring up in this context is, I don't know whether to characterize it as AI for DB or DB for AI, which is what, for instance, Google's Alloy DB did, where they allowed you, as part of your database SQL invocations, while you are accessing the data in the bowels of the DBMS, to be able to invoke, just like you have user-defined functions, the Vertex AI calls. So instead of dragging the data out of the database system before you feed it to ML algorithms and such, they're letting you, within the DBMS itself, as needed, invoke these AI subsystems functions so that you can minimize the movement of data and such things. Just like applying, image predicates and things like that to the context of more traditional databases. So this is a way of marrying, if you like, AI systems with database systems and not try to treat them as totally distinct entities and having to extract out data from the DBMS before you are able to combine it with the functionality of
so a lot of things actually, as we talked about, kind of a swirling pattern that some of the topics were mentioned or discussed or studied or researched maybe decades ago, but under a different framework. And now it resurfaced.
Coming back. Right?
When I was at Sybase in the 90s, they have a very cute product called Omni SQL. It was kind of dealing with all sorts of data sources, and I will combine all the data resources, and you can query through one single kind of interface, and I'll go to search all that.
In a sense, that's what Spark also has done, right? You have these remote data sources, and using Spark SQL,
as long as
trying to make it appear as if all these distinct data sources, heterogeneous data sources, are all like a single database with SQL as the data model using which you can access it. And so this again goes back to the Garlic project that was done at IBM Almaden, where it was heterogeneous data integration technology that was developed with wrappers being attached to each of the remote sources, which tried to make the distinct data models of these remote data sources appear to be a simple-minded relational model, because the wrapper does the transformation.
I think that's a forever topic.
That's true. It's only getting even more messy now, because now you could think of the LLM itself as a source of data. There's a lot of efforts now, and this was especially true of last year's ICDE conference, where they are trying to combine a traditional LLM with the data models that are supporting, what do you call those things, knowledge graphs and so on.
We actually have.
So there is curated data that's produced in the form of knowledge graphs, and then you have this mishmash of stuff all the world's data that some of these LLMs try to swallow and make sense of when you have lots of inconsistencies. And that's where I was saying the Granite data model tries to resolve inconsistencies and not treat every source of data equally and try to, assign more which data sources are more trustworthy than which other data sources, and try to do data cleansing and things like that, eliminate duplicates, get rid of profanity and stuff like that. So
that's interesting.
Right. So shall we switch topic to DB for AI? Right. You mentioned the agentic, programmings or whatever, using like what you were doing. It's just a personal task, but you're dealing with an AI interface. You're using obviously LLM in the back, but you also leveraged, I guess, a smaller database on your own, plus a huge database on the server side. So these are the database infrastructures on the back. What do you see on this DB for AI direction or trend?
The first trend is the interface is very important. I think
interface,
or because just like I said, all the question I ask to my agent
is
natural language.
Right.
My agent will translate this task into several SQLs, and even sometimes it will write a Python application to try to
imperative program.
Embed it into the program. So I think in the future that will create the middle layer between the LLM and the actual database. That's
between LLM and do you think that's SQL?
SQL is part of this. SQL will become the IR. It's more like it will not transparent to the
end user, right? Right.
So you can consider this a new kind of SQL optimizer. Translate the user's demand or request into
some intermediate form.
Yes.
But on that front, should I ask that you think the SQL that the LLM is generating is good enough?
Yes.
So you have that trust.
I believe in
not only from semantic,
not
only from semantic perspective, but also from performance and overall impact perspective. I can have a query that writes very complex. That's correct to interpret my intent, but the SQL it wrote was so complex and causes this huge impact to the system.
It used to be a
would that be a concern?
4GL tools of the past, where they would crank out many pages worth of single SQL statements,
or business objects,
and it would be terrible in terms of performance.
That will lead to my second, I think I would say opinion, which is today the whole industry not putting too much attention, not enough to the multi-tenancy architecture. So, for example, that's why I'm thinking maybe building a database as a service is totally different from building a database as a software. For example,
for this purpose.
For example, if you're writing the very bad SQL, if the flow control layer or the multi-tenancy layer will kill the SQL immediately. So it's like I really like DynamoDB team. They published the paper in 2022, which is how they build the traffic control layer on top of DynamoDB. That paper is very interesting. So instead of building a very smart SQL optimizer to avoid this, I want to build a very smart traffic control layer to to not allowing this kind of bad SQL
to come in. Or identify it at the right timing and kill it or whatever, right?
This is one thing. The second thing is, I think what you mentioned is about the big data. But I think the trend is data become the target. The data you want to analyze, the data volume is not big. Is becoming smaller and smaller. That's just like
the personalization.
The personal, the enterprise. For example, today's most of the RAG system, a lot of enterprise want to build their internal RAG AI chatbot. We have a lot of customer using database in this style, but when you take a look at the workload, you find that how many documents, how many chunks are there even for the big enterprise, like million? Smaller, yeah.
In fact, that's one of the points I make about enterprise level AI and such are different from when you are analyzing social media or e-commerce kinds of databases, because there the volume is very high. But in the enterprise context, even for training to build models, forget LLMs for the time being. If you look at more traditional AI model development, to train them, you need vast amounts of training data, and that's not available in the enterprise context because there aren't really that many enterprises where you have the same, exabytes of data and such that people talk about.
And I think the difficulty for you guys as a database vendor is you don't necessarily have the each enterprise specific, usage data or, performance data as your training data to improve your optimizer.
In fact, what I've heard from the cloud vendors is that they are not at liberty based on the agreements they have with their tenants to willy-nilly combine data about these different tenants. Even if they have it, they are not allowed to combine it with other tenants' information.
I guess that's the challenge of what's the term? Trusted infrastructure or trusted computation
provider, and
so you can either under a legal agreement or under a technical infrastructure, I can touch your data, but I'm not really seeing the true data. I'm seeing the characteristic of the data, right?
But even some of that they are worried about.
I know. That's
revealing some trade secret and this and that, and so they put stringent restrictions on what the cloud vendors are allowed to do.
Especially for AI, I don't necessarily. That goes back to my trust question. I don't necessarily know what your AI agent is exactly doing, and with illusion, with your convergence, of course, I have sort of a hope that you may come up with something I don't know that would benefit me, but at the same time,
that's where I was talking about this indemnification law.
At the same time, I fear that you may come up with something I don't know, and that would hurt me.
But that's why I think just like I said, the SQL will play a very important role here because you can consider SQL is like a DSL, the domain specific language. Because when the AI agent, they want to generate a report, you don't want to believe that you can review the whole process. But in this part, SQL is readable and reviewable by human being.
And that might reveal some, modes of operation of the enterprise and their business model and trade secrets about how they do pricing and such.
But funny is we talk about AI for DB. I would imagine once you have that role clearly defined, you're going to design some agent to replace that human being because that sounds like or looks like something can be replaced.
But the point is that stuff cannot be revealed to other people. It's a bigger point, right? Whatever inference you make of how this company works, cannot necessarily be leveraged in doing something.
That's fair.
The target is not to replace human being. It's like, maybe 99% the job will be done by the AI agent, but maybe 1% still need a human expert to review, to modify, to be working together. It's not like the AI will replace all the human beings.
Sure.
But the analogy I use with cost models and such, in the good old days, if you looked at how detailed a cost model that the DB2 mainframe developers built, it was far more sophisticated than what Pat Selinger and company did for System R. And so it used to even take into account things like what processor it's running on, what kind of disk drive it's running on, what its seek time is, what its rotational delay is, and so on. But once you go to the cloud and all this virtualization business, it's so different now. And also the heterogeneity of the various kinds of hardware and other resources is also multiplied like crazy. And so that's why dynamic adaptation and dynamically inferring what environment this particular system is running in, and as time goes on, how it changes, all of these sorts of things are places where adaptability and not hardwiring stuff has become an important characteristic for a database system.
I will share the example. We have an AI company actually using TiDB for their backend. DeFi, I think DeFi is heavily used TiDB. They create near 500,000 clusters on our cloud.
500,000
clusters.
Oh my God.
That's the number of processors.
Numbers of cluster, because
it's public information.
Yes, public. They share the blog post and everything.
Sure.
Because they have a lot of agent or the tenant. Every tenant runs when they have an AI job, they will create the cluster, create the task. The biggest database in DeFi's case is just the biggest ones are near 100 megabytes.
Oh wow, that's so small.
Yeah, very small. And near 90% of the cluster is just one time and the code data. So that's why I'm thinking maybe in the future the how AI or how this AI agent use database, it will be in a very different, very dynamic.
Not highly integrated databases, but lots of itsy bitsy autonomous databases.
Exactly.
And again, I think you're right, because once you say that, if you have so many instances of AI agents all over the place, and you're assuming a small set of data that needs to be fed into these agents, then
the challenge of a different scale.
Exactly. The challenge to that critical data set or database is going to be changed.
But also, this reminds me a bit of the distributed learning scenario where each of the remote data sources doesn't want to reveal the details of how it operates, and it wants to only give a high-level information which can then be combined. So in the distributed learning scenario, they build distinct models for the different individual data sources associated with which is a lot of secrecy, this, that, and so on.
Right.
And then they combine the individual models into a global model. And so this smells like that.
Yeah. Very, very similar.
That's
to that.
interesting.
Yeah, very.
Right.
Oh, sorry, gentlemen, I have a hot stop.
Right.
But really
It's great to have you guys on our show, and thank you.
Thank you.
And thank you, Nathan, for being our videographer.